Do you have to edit a long document and want to save your time and effort while producing a beautiful and high quality typesetting? Are you looking for the best typesetting tool or just want to learn and master new word processing tools? Whatever your requirement is, the answer is LaTeX. Hi everyone and welcome to the LaTeX tutorial. Let's get started and see first what is LaTeX. LaTeX is a free software package created in 1985 by the American computer scientist Leslie Lamport as an addition to the TeX typesetting system. LaTeX was created to make it easier to produce general-purpose books and articles within TeX. LaTeX allows to produce long documents such as reports, theses, dissertations, and books. It perfectly handles mathematical expressions in a flexible and easy way, and it allows also to draw plots and diagrams through the use of a wide variety of packages that you can add to your document. Besides, LaTeX separates the content from formatting, just like a CSS style sheet does for an HTML file, by the use of style classes, which makes formatting and designing documents an easy task. For the preceding reasons, LaTeX offers significant long-run time savings. Many users find that typesetting in LaTeX becomes increasingly fun and convenient over the time. Because LaTeX is open source, you can also easily share your content with other teachers and collaborators without version compatibility or licensing issues. Thus, it comes with a free cost. Let us first see how to use LaTeX. The first option is to download the software locally that allows you to create TeX files. This will require also to have a TeX distribution. If you are under Windows, for example, one of the most known applications is MikTeX. If you are using Linux, you can download any TeX package like TeX Live and use any text editor in order to edit your source code, then compile it to get your final document. Under Mac, you can use the MikTeX distribution, for example. The second possibility is to work online, which is much easier than downloading a specific software. This will allow you also to store your files remotely in the cloud and also to share them with other collaborators. One of the most known solutions is Overleaf. Use Overleaf, you don't even have to create an account and just connect with your Google account. You can set the language, as you can see here. You click on the language that you prefer. You can also create projects and see your projects if you click here, and you can check your account settings and log out from here. You can create a blank project, an example project. You can upload a ready project or import a project from GitHub. You can also use some specific templates. Let us create our Hello World project. Creating documents with LaTeX is simple and fun. In contrast to Word, you start off with a plain text file which contains LaTeX code as a markup language. Then LaTeX uses control statements which define how your content should be formatted. Before you can see what the final result looks like, the LaTeX compiler will take your TeX file and produce a PDF file. So let us start with a simple example. First, we have to specify the document class using this command. Everything that appears between brackets is square brackets is optional. So I'm going to remove the option and just specify article, which is a predefined class for formatting articles. After that, I have to wrap the content of my file between begin document and end documents. Here I can provide everything that I would like to see in my document. Here we will just print Hello World. We can compile this file under Overleaf just by saving the document or compiling the document. So here, if you click on Recompile, you are going to get a PDF file that contains Hello World. Of course, you can upload this PDF file from the menu. You can get a PDF, as you can get the source code as a zipped file, which contains all the files you have in your project. You can also specify the compilers, the TeX distribution, and your main file. As you can see here, the first line of the document starts document class and the word article between brackets. Every line starting with a slash is a command in LaTeX, and it has some options that are provided between brackets. Then we have begin and end document. So begin and end specify an environment in LaTeX. Here we are using the document environment, and we will see later on many other environments that we can use. How to add a title. Let us now see how to add a title to this document. So simply we have to provide the title command. We can give the title here, for example, CPIT 221. Then we can provide the author name, as well as the date, of course, using always the dash to provide the current date. And this title will be displayed if we use the make title command. But be careful here, the make title should be in the document environment, not before the begin document statement. So if we compile, we will get this new output. So this is our document. This is the title displayed here. This is the author name as well as the date. We can move this hello world to another page by using a new page command. And this will give us this document, PDF file, where the first page only displays the document information and the second page displays the content. Of course, as you can see here, we got numbers for the pages. This is coming from the article package. If we would like to remove this number from the title page, we can simply add this command, page numbering, gabble. This command will remove the page number everywhere, so we have to recover it just by using the same command and providing the option Arabic to recover the page numbers for the rest of the document. So as you can see here, the numbering starts from the second page, not from the title page. Structuring the document. When writing long documents, it is important to structure the content into logic units. To achieve this, LaTeX offers us commands to generate section headings and number them automatically. We have sectioning elements like section, subsection, paragraph, subparagraph, and so on. So let us create some sections here, like the ones that are in the example: introduction, motivation, background as two subsections of introduction, then main content and conclusion. So to provide this document, first we have to define our section using the section command. Then we provide the section title between braces. So here, for example, I will write introduction, like that. If I compile the document, I will see the first section appearing here. After this content, I will provide two other sections. Background, for example. We said also that we have another section called so this is the main content. We have said main content. We will try to reproduce the same document, and this is going to be the conclusion. So here we have created three sections, as you can see here, that are automatically numbered. We can add subsections inside a specific section, like here, subsection, Then we call it motivation. We can also have another subsection that we name background, for example. The next unit that we have is paragraph and subparagraph. So we can have paragraph P1, let's say, then some text here. This is going to be displayed as following. So this is P1 and some text here. We can have a subparagraph. Let's say P11 and we have here our subparagraph with an indentation. We might require to add an item list, for example, inside the text. For example, let's imagine some bullet items. So to add this item list, we either can use the environment itemize if we don't need numbers, we just want bullets, and each item will be preceded by a slash item. For example, Latex is easy, it is powerful, and it is funny, for example. So this will produce a list like that. If you would like to have a numbered list, we just change the environment from item list to enumerate. So begin enumerate and end enumerate instead of begin itemize and end itemize, and this time we are going to have numbers instead of bullets like that. Having a structure for the document using LaTeX is simple and easy, as we just already saw, and it allows us also to create quickly the table of content with just one command. So to add a table of content, we have just to type the self-explanatory command table of contents. So if we put it here, it will just be inserted after the title. If we compile, we will see our table of content appearing here that contains the sections and subsections we have created along with their page numbers. Once you mastered how to create a basic document, it's important to know how to add figures to the document, as it's an important element of any written document. LaTeX offers a lot of functions by default, but in some situations it can become handy to use so-called packages, which are some files that we are going to import in order to add more features to our file. To import a package in LaTeX, we simply add the use package directive to the preamble of the document. So for example here, if I would like to deal with images and add a picture to the document, I have to add a specific package that will help me to insert a figure. To do that, we have to proceed as follows. First, we add the use package command, and we provide the required package. In our situation, it will be graphics. Then let's say, for example, I would like to add the figure in this subsection, motivation, just after the item list. So we have to add an environment, of course it has to start with a slash, begin figure, and the important part of the code, as you can see, is already inserted by the compiler. So here we have the command centering that will center the picture. We have then the command include graphics that should take the path to this figure. I have already uploaded the figure that I would like to add here in the same folder with my main file. So this is the image that I'm going to insert. So I'll go back to the main. Then I have to provide the path. Since it is in the same folder, I will just write the name of the figure, which is CPIT 221, and it already appears here as a recognized image inside my current folder. In the caption, we have to provide the title of the image. So here, for example, I will just call it CPIT 221. All right, we have also something called label. The label in reality allows you to reference a specific figure. So if I give a specific label to the figure, let's say fig1, I can call or reference this figure in the text. For example, please see figure. So how I can reference the figure, I just have to use the ref command and provide the label of the figure that I would like to reference. So if we compile this, you are going to see the figure that I have added. It has a title, it has automatically got a number, it's figure 1, and if you go to the text, you are going to see the number of the figure that appears thanks to this reference command. So this is very flexible, because if you add images to the document, it will not impact on the numbering of the figure, since you are not doing this manually, but it will be handled automatically within the labels and references that you are using through the Latex commands. The last point that we are going to discuss is how to add tables to the document. Now we are going to learn how to use the table and tabular environments to create tables in LaTeX. We will start with a simple example. Suppose we want to create a table in this section, main content. For this, we will provide a begin table environment. We need to close this environment, of course, with an AND table. And inside the begin table, we also require to use the begin tabular environment. This is to create rows and columns inside our table. We can specify here between brackets the options for our table by specifying the number of columns and the separator between columns. For example, if I would like 3 columns like the example I have here, I have to specify the alignment for the columns and the separator. So we have a vertical line as a separator between these columns, 1 and 2, 2 and 3. So I will provide 2 vertical lines. Then my first column is centered, so I will use the letter C, small c. This one is aligned to the right, so I will provide letter R, and the last one is aligned to the left. Then I can provide my rows. So the elements inside each row are separated with the ampersand symbol. For example, the first line is the header and it contains column 1. Then to move to the next cell, I provide the ampersand symbol. Then I provide the content of the second cell, which is column 2, and so on and so forth. So I have here 2 ampersands because I have 3 columns. This is column 3. Then to move to the next line, we have to go to a new line using 2 slashes like that. And we can add a horizontal line or 2 horizontal lines using the command hline. So here we have provided 2 horizontal lines like that. And we do the same for the rest of the table. So here I have row 1. I have
another cell containing C11, and finally the last element is C12. Again, I have to move to another line and to add a horizontal line. So if we get to look to this output, we will see that we have created two rows and 3 columns. We will finalize with the last row, sorry. So this is row number 2, it's rather number 3. But we consider that the first one is the header, so this is cell 2.1 and this cell is 2.2. Of course, we can add a caption as we did for a figure, so we add the captions here, caption, my first table. And of course, if we add a caption, it's recommended to add a label so that we can reference the table in our document. So for example, we can specify that this is a table called tab 1. And I can reference the table here, C table, like that. So let us get a look to the output. So everything is fine except that we didn't add yet the first horizontal line, which depends on your preferences and your flavor, how you would like to design your table. And also we would like to center the table and see it in the center of the line. So we can do this by using the centering command, or by wrapping the table between a begin center and end center environment. Like that. And of course, as you can see, we are referencing correctly the number, so LaTeX has assigned number 1 to the table, and this is a flexible and easy way to deal with the numbers of your floating elements in a document. It is important to note that LaTeX is not only used to format and create documents, it allows also to create posters, so you can check the gallery for posters under overlay where you can find many templates and layouts for scientific posters. And of course you can switch from one template to another easily, since there is a good separation between the content and the layout. It also allows to create books, so you have also a wide variety of templates for books, generic books that will simplify the edition of long and big volumes. And it also allows to create CVs, so you can also find a big variety of templates and styles for creating your CVs that you can also personalize depending on your needs and flavors, and even presentations. So it's possible using the Beamer theme to create a PowerPoint-like presentation, and it allows to navigate between slides easily. You just provide your content, then you can switch from one template to another quickly and easily. So we can find many themes. As you can see here, you have just to specify the name of the theme in order to switch from one theme to another theme, as you can personalize your theme, of course. If we check by color, for example, we will find other themes, and we can check here many possible themes that can be used for a presentation. So each theme defines specific environments, like an environment for boxes, like here, and they are very flexible, as you can see, for mathematical equations. If you have a presentation that contains many mathematical equations, then LaTeX is your best choice. Finally, these were the main references used for this tutorial, and I hope that this material will be helpful and useful for you.